Well, good evening, guys. How's it going? Thank you all so much for tuning in, and happy Wednesday to each and every one of you. I'm deciding to keep like the darkness theme still in these videos. I think it's sort of relaxing on the eyes, at least for me when I'm looking at my screen as opposed to when the light's on. I know I'm kind of weird like that. I'm probably damaging my eyes in the process, but I actually do kind of like the evening ambiance. It's very calming. So I'm gonna keep this. I mean, you guys can kind of see my face. It's a little bit lightened up in blue. It sort of reminds me of the Blue Man Group, but I guess we'll rock with it for now. But tonight's discussion is really going to focus on the severe threat for tomorrow. I'm not going to be talking much about the winter weather threat for, say, the lower Great Lakes. I mean, I might. I think we might later on towards the end of the video. But the bulk of discussion for at least this evening is going to be for this enhanced risk of severe weather for southeastern Texas. Now, what I want to do is something that I typically don't do in these video discussions, and that's actually dive through the SPC discussion. Or the SBC synopsis, right? I'm not going to go through all these different points. I mean, this is a lot of information, and this is, keep in mind, these SBC discussions aren't necessarily meant for the public. This is just a lot of technical jargon to give you sort of the ins on what sort of they're thinking through in these forecasts. But what I can do is sort of help to translate a lot of this technical jargon and sort of, I don't want to use the word dumb it down, but at least translate it so we can all understand it together. So I want to point you to this paragraph, right? They talk about all the ingredients that we have. I mean, we're going to be talking about, 60-degree dew points, which is great, right? We got a lot of moisture to talk about here in the boundary layer. You got a surface low, we got a shortwave trough that's going to go negatively tilted. All those things sound great. I mean, it also mentioned the fact that our vertical shear profiles are really nice. We got curved photographs. We got elongated straight near 3 kilometers. That's really good if you're trying to look for supercell development. 40 to 50 knots at 850, really strong low-level flow. All of this seems great, but what I want to kind of direct you to is this next paragraph. Low-level thermodynamics appear problematic. Surface temperatures and dew points may struggle to reach higher than 68 to 69 degrees Fahrenheit, except perhaps near the immediate coast. Furthermore, cloudiness and morning convection will limit heating, and forecast soundings indicate low-level lapse rates remaining quite poor and nearly moist adiabatic. HREF members also continue to depict stronger negative UH tracks, that means updraft helicity, than positive, which is an indication that storms may struggle to be rooted near the surface, limiting access to better low-level vertical shear. Yada, yada, yada. So what that essentially boils down to in this paragraph is your boundary layer is kind of garbage. I mean, that's like the best way to put it, right? The reason why, which you'll see here on the models in a second, is because when you have your temperature and your dew point pretty much saturated, right? And then you also have not just that, but a whole bunch of cloudiness going on and a bunch of morning convection. I mean, you can have a temperature and dew point that's somewhat close together at the surface, which is what we call saturation, essentially, or equilibrium. The problem becomes when you have a lot of convection in the morning and afternoon. The reason being is because we want some clearing within our parameter space or our sort of environment to where we get diurnal heating and essentially a increase in potential energy and an increase in instability. You can't get that if it's just going to be cloudy and constant shower and thunderstorm activity throughout the afternoon. At that point, you're pretty much exhausting the energy that you have to work with. So let's actually sort of put this in motion here on a model, right? So we'll take a look here at the latest NAM nest, and we can also look at the HER too. Either one is showing the same thing. So this takes us into 0Z. This would be essentially tonight, right now at the time of this video. And as we go into tomorrow morning, this is 12Z, right? We got a lot of shower activity. Now, there are some clearing pockets, right? There's some spots, say in the Dallas Metroplex, we got some clearing, maybe some clearing out towards Houston, but there's a lot of shower and thunderstorm activity, quite a bit, and that just grows throughout the day. Keep in mind, this isn't even our front. Our front is actually back here, That's our cold front. We have sort of a cold front and then a warm front placement. So in this case, right, if we're just seeing nonstop showers and thunderstorms throughout the entire day, you have no opportunity to really create instability in this environment. Is it going to be unstable to produce showers and storms? Yes. But it's not going to be allowing for enough instability for proper diurnal heating and daytime heating throughout the day to where you create an instability sector that would promote clearing, promote diurnal heating, and thus more robust severe weather chances. In this case, this pretty much poo-poos that idea because we'll just see a lot of showers and storms just training throughout the day because we're going to get some really nice low-level advection. And that's going to produce, moisture advection as well as warm air advection too. So as you can see by the NAM nest, that's a problem. Now, if you want to look at another solution like the HER, it's pretty much showing the exact same thing. And if I was to look here at the 1Z, just even like the latest run, we'll see, 2Z is not done yet. But if we want to look here at the morning, same situation. These are not light showers, guys. These are thunderstorms, clusters of thunderstorms that are moving through in the morning. That does not leave enough opportunity for supercell development. Now, the exception to the rule could possibly be down along the coast. You could see that, right? You could see the opportunity as some more, semi-discrete activity, but that really remains to be seen. Ultimately, what the Storm Prediction Center has decided to do for southeastern Texas is, essentially say, you know what, we're going to keep the enhanced for now until tomorrow morning. Because one of the things that's really important in forecasting, guys, is we have these models that are showing this kind of output, but we really don't know 100% until tomorrow morning when it's actually happening. And I know that's kind of like, it goes without saying. I mean, that's pretty straightforward, right? That's how all weather is. But in this particular case, if we have a situation where, let's say there's a lot more clearing tomorrow in a place like Houston tomorrow morning, to where, yeah, you have showers and storms that are scattered about, but there are some pretty big pockets of clearing. Well, that could be enough to produce instability at the surface and the boundary layer. Then we could be talking about an enhanced still. But what the SPC is essentially saying is, yes, you have really strong low-level advection. Great, right? Awesome. You also have a pretty modest westerly flow, which is an association with this negatively tilted trough up towards, say, the Panhandle. Great. Synoptic, mesoscale, everything's great. But when it boils down to it, we have to refer to the acronym called SLIM. Shear, lift, instability, moisture. Do we have moisture? Well, I mean, we didn't look at the dew points necessarily, but we know just based off this output of reflectivity, we must be pretty darn saturated or close to it. So we have moisture, right? Otherwise, we wouldn't have this widespread convection here. Do we have shear? Well, I mean, just based off of, say, what the SPC said, and we'll look here at a sounding in a second, if you have about, say, 30 to 40 knots from surface to 1, surface to 3, yes, you do. That's more than enough. So you definitely have shear. Do we have lift? We have a warm front. We have a cold front. So that would be our lifting source. The answer would be yes. Do we have instability? That's the question, right? As I said, it's unstable to where we're getting thunderstorms. Otherwise, we'd be stable if we weren't getting thunderstorms. But it's a matter of how unstable. And so to do that, let's take a look at a forecast sounding. Now, I am going to cheat a little bit tonight, just for the sake of time. And I think what I'll do is I'll pull from the surface. I'll use supercell composite. I know that's kind of sacrilegious to do, but I am going to do it for the sake of conversation here. I'm going to look at the NAM nest. Let me go just kind of, we'll just pull a sounding here. And this would take us into what would be later Friday night. So taking a look at this sounding on the NAM nest. Looks like we did have surface cape at about 1400. And by the way, the College of Dew page does take a little while to load these soundings up. It is rather slow. But let's see if it does it. There we go. Okay. So in this case, our cape, by the time we get to later on in the evening, well, I mean, the NAM nest might be a little aggressive here. We're talking about 1500. Well, that's actually pretty decent. Okay, that's not bad. PWatt 1.23, yeah, it's saturated. I mean, look at our temperature dew point are right on top of each other, and you got some drier aloft. Okay. You also have veering. We have our shear. We talked about that already. There's our shear vectors as well as our directional shear. We also have our moisture, which we just mentioned. The instability, okay, we have Cape. Great. These lapse rates, though, throughout the day are really low. Now, this run is showing 5.6, which, I mean, is okay. It's not great. But even before that, if we talk about early on in the afternoon, I mean, this is 3Z. You're talking about like 9 o'clock at night. Even in the afternoon, our lapse rates are even worse. I've seen runs that show like 4.6 Celsius per kilometer. So just think, as your parcel is rising with height between, say, surface to 3 kilometers, in this particular scenario, you'd be talking about it's only decreasing in temperature 4.6 degrees Celsius per kilometer. That is not very unstable. It's unstable, but it's not to where it's, you would like to see that number be a lot higher, at least in the sixes at most. But 5.6, that's really bad. That's too low. And same thing goes for the 800 to 500, 5.9. 3 to 6, even 7 to 500, 6.1. These are low sixes, high fives. Not great. Okay, so the thermodynamic instability is really not all that hot. Yes, the Cape profile is somewhat decent, at least on this particular run. Yes, you have shear. Yes, you have moisture. And yes, even your HODO is pretty decent, right? This all looks great. The problem is your lapse rates are pretty garbage. Not great. And also 2 degree or bulk shear is okay. But really the main focus here is this. Your lapse rates are way too low. And even still, I would make the argument that with this Cape profile, I actually expect to see Cape somewhere between, say, I don't know, we'll call it 800 to about 1,400 joules per kilogram, like throughout the entire day. I think that's pretty much the maximum. So Cape is okay, but again, the biggest problem is your lapse rates are not looking good. And also there's somewhat of a correlation to even the precipitation, right? If you've got a lot of shower and thunderstorm activity, how much Cape is there going to be available if you're exhausting that potential energy? So there's a lot to think about here. And again, there's an enhanced risk right now, but if you're wondering why people aren't going down, some of the more notable chasers out there, Connor Croft, I think Vince Willetti is not going down there either. I'm not sure, but I know quite a few people aren't actually chasing that because there's a lot of questions about this setup. It's really one of those where it's a low floor, high ceiling event, right? I mean, it's basically either going to completely bust or it could actually turn into something. It's really one of those two things. So hopefully this addresses sort of where we're at with this overall setup. If you want my opinion on it, I do concur with the SBC. You got to wait till tomorrow morning's observations. We got to get a weather balloon up there tomorrow morning in some of those offices. It's going to help us sort of show if things are on track with what we expect right now. And if they are, would not be surprised to see the SBC downgrade this thing to a slight at most. We'll keep a close eye on it. We'll definitely keep a pulse on it going into tomorrow. Certainly something very fascinating to keep an eye on. And as I promised, let's go into the immediate term with the winter weather. Let's kind of address the elephant in the room about the lower Great Lakes to kind of top off the conversation tonight. One thing I want to mention too is I didn't mention this at the top of the video, but be sure to like and subscribe, share with family and friends. Also, if you have any questions about any weather for your area, post those in the comments below. I haven't seen much activity quite yet, but please take advantage of it. Honest to God, I will respond to every single comment. If you have a question about your location that we don't cover in this video, or if you want some clarification on something that we talk about, I'd be happy to address that in the comments. That's no problem at all. So this is taking a look here at the NAM 3K. Now this is our system of concern, right? So we got a lot of shower and thunderstorm activity for the southeastern United States and even back towards the Gulf of Texas. What I really mean to say Texas, not necessarily southeast, but mostly the Gulf Coast of Texas and Louisiana as well as Mississippi, Alabama. Well, that continues to move off towards the north. We do then have cold air, enough of which to wrap around and produce snowfall for our folks in Kansas, right? I got a lot of questions about Kansas City, if you're going to be getting snow. Well, at least according to the NAM Nest, it's going to keep most of the snow to the north. But because of how close that rain-snow line is, I mean, we do have to be kind of careful about that positioning. But as we go forward, you do notice that by the time we get to Friday morning and afternoon, we get some snowfall for far northern reaches of Illinois, central Michigan. Could be seeing some accumulations there. As that continues to move off. And then it also then kind of fires off a secondary wave of snowfall by Friday evening and into the overnight for Saturday morning. So if we look here, at least from the snow total point of view, actually before I even do that, I'll show you just the general, the jet stream here, right? So like I mentioned before, I mean, we do have sort of a two trough system. This is our first shortwave trough that moves through, very negatively tilted as it cuts across the lower Great Lakes. It's a great sign if you want snowfall, because a negatively tilted trough, essentially by it doing that, is actually going to, from a synoptic scale, bring back cold air. So it's going to advect cold air, and then you're going to advect warm air, and that's essentially how you get your stronger jet flow in the mid-levels, that thermal gradient that sets up right in the middle there. Could see some nice precipitation in this area, pretty high totals that I've seen just from the rainfall point of view. And then this would actually keep our snowfall more towards the north. But if we want to identify where that sort of rain-snow line sets up, we look here at the 850. This takes us into Friday. You notice that your strongest of your low-level jet is really going to be confined to Kentucky, Tennessee, as well as Mississippi. Meanwhile, your warm front itself is actually going to be set up right here, right? It's going to be somewhere within this area. So at the moment, it looks as though places like Rockford, Freeport, up towards Janesville will likely get in on the snowfall, but it's going to be a pretty thin corridor because it's sort of still a split flow regime. Let's actually zoom in here to Illinois and show you some of these snowfall reflectivity here. Again, this is our low-level jet, and as you can see, you can actually notice it right here on your low-level flow. Right, you get moist air advection that feeds into this thing, but then you sort of get this easterly wind component. This is where your warm front is setting up, right in this area. And your snowfall will actually follow that corridor. So see right here, this is your low. This is where your precipitation shield is going to be. So if we move ahead, and we'll show this here on a map in a moment, but on this low-level jet, you do get this nice precipitation gradient to set up right in this corridor. And you can actually see that on the, this is actually the 925, correct me, it's the 925. You can actually see this. And to be quite honest with you, if we were to look at the low-level jet on 850, right, same thing. We could be getting some stretching here. This is a synoptic term. I'll have to look into this further. I don't want to give too much information overload for you guys in northern Illinois, but could be some dynamic stretching that's going on here with that snowfall banding. And I'm particularly concerned about that. I'll have to read into that and see. But just from the sheer view of those 850 wind vectors, it looks as though we get some banding to set up there. That could mean for some locally heavier mounts. Whenever I see banding like that of wind vectors in the 850, that could likely mean some form of frontogenesis going on with our warm front. But secondly, we could see some heavier snowfall rates. Again, this is also looking at the NAM 3K, so we got to be mindful of that. But at least just for now, I mean, that's rather interesting to look at here. So let's look at the overall winter precipitation, or just what the output would be on reflectivity once more on a close-up view. And then we will look at some snow totals. And so as we go forward here, guys, look at where that freezing line sets up. That's right here in, say, the western suburbs. So the western suburbs of Chicago, far west, looks like, once again, Rockford, Freeport, Beloit, probably just up the I-90, I-39 corridor by Janesville, just to the south of Janesville and to the south of Madison. Could see some snowfall even up towards Milton and Whitewater. And then as that moves towards the north, you get a second round of snowfall that forms. It's sort of that banding that takes place, and we'll have to, again, keep a very close eye on that. I'm particularly concerned right now about what the NAM nest is outputting. We're going to look at one more different solution here and see if this is sort of a confidence in this type of scenario. But if this was to come true, I would be particularly worried about far northern Illinois, particularly right by the I-88, the I-90 corridor, and then up towards 3990 by the time we get to Friday afternoon. But we're going to take a look at another solution here and see if this is the case. Before we do so, let's look at some snow totals on the Kuchera. And if we kind of go forward here, this doesn't look like a lot. I don't want that to deter you though, right? Because what I'm particularly worried about is not necessarily the amounts. Notice how quickly that falls. Okay, so we go from, say, like, keep an eye on, we'll just say Rockford or DeKalb. So DeKalb's right here. Watch what happens when we go from, say, 14 to 18. We're talking about, say, 4 to 5 inches of snow within a 4-hour period or a 5-hour period. So you're averaging close to about a half an inch to an inch per hour of snow. And a lot of that has to do with the overall dynamical stretching that can be taking place. It's a term we use in meteorology. It also could have to do with the fact of, we could see some pretty significant frontogenesis taking place and tilting and stretching, like I said, which is all, dynamical terms we use in weather, pretty significant if we're looking for quick snowfall. So if you look at this, again, this is the NAM nest, but if we're going off just this solution, I'm not concerned about the snow totals. What I'm more worried about is how quickly that falls. The quicker that falls, then the more intense the snowfall is. The more intense the snowfall is, the sharper your visibility is cut down. So we need to keep a very close eye on that. That's particularly concerning to me. I always look out for roadway safety. I'm always a proponent of that. And if we're seeing these type of snow totals fall that quick, that's a problem. The other model I wanted to look at here, at least to see if there was some sort of correlation, is the HRRR. And we'll look at the 0Z and see if that is the case. And we'll just kind of keep going and going and going and going and going. Now, the HRRR, interestingly enough, doesn't show that much. And it also shows it falling, well, still rather quickly, but not as much, with some areas getting about 2 inches near Sterling. So I guess to end off the video, let's see why. And there you go, right? The reason why is because, at least according to this model, the NAM nest tends to be a little bit more aggressive the NAM nest was more aggressive on the northern flank of this low, whereas the HRRR is not. So we have some disagreement here. And so I guess what I'll use for kind of the last note is maybe just look here at the NBM and see what they're outputting. Right now, it's sort of within a few tenths of an inch. The NAM nest looks to be the only outlier right now, but it is something we have to monitor because that certainly still is a possibility. So if you're in northern Illinois, if you're in southern Wisconsin, especially along the state line region, pay close attention to this over the next day or so. There, to my knowledge, is not any winter weather advisories. I don't think there is, because there's only one solution that is showing the one that I'm worried about, which would be the NAM nest. And no, right now, no winter weather advisories at this time, but it is something that we are going to keep a very close eye on. Weather Service in Chicago, it looks like they are pointing to that. But, again, there is uncertainty, and they kind of mention that as well. We'll keep a very close eye on that. We'll also keep a close eye on the severe weather that is expected for the South, particularly Texas and southern Texas going into tomorrow. Again, if you have any comments, questions, post those down in the comment section below of the YouTube channel and of this video. And with that, I hope you all have a great rest of your night. Take care, and we'll see you back here on our next weather video. Take care. Bye-bye.